Guys, welcome to section 7.3, where I am going to be illustrating for you the problems from the skill check to give you a little bit of extra practice with what's going on. So I am in chapter 7.3 of our text, which is Pre-Algebra for Christian Schools. It's the first edition published by Bob Jones University Press. The title of this section is, if I could find it, Solving Equations Using Multiplication and Division, and we're working with rational numbers now, which of course are what you know of as fractions. First edition is laid out differently than the second edition is. You can still use the same gain from this material. So let's go ahead and pray right quick. I've got a lame joke for you, and then see what we can learn from these 10 problems I'm going to work for you. God, you are awesome, and we are totally in awe of the holy God that you are. And once again, Father, thank you for the reminder at Christmas of the greatest gift of your Son, Jesus, that you gave to us. Father, I ask that you'd help us to learn the things that we need to learn, to be diligent in all that we do. And I pray in Jesus' name, amen. Okay. My joke for today says, my question joke, why did Johnny jump up and down before he drank his juice? Okay. Well, the carton did say to shake well before drinking. So, we are working with algebraic equations that involve fractions right now. And we're going to see that we can solve those exactly the same way that you would solve any other equation, just by using inverse operations. And since you already either know how to do these problems or you've watched the companion video, let me jump right to page 226, where we have a problem. 3a is equal to 5/7. 3 times a is equal to 5/7. Now for this problem, all that they are asking you to do for these first 4 problems, it says, describe the operation that you would use on the first step to solving these equations. They're not asking us to go through the whole way. They just want to see what are we going to do first. Well, what do you do with any algebraic equation? You look and you see what operation has been performed on the variable. What have they done here? They have multiplied a by 3. What are we going to do? What's the inverse of multiplication? Well, that's division. So we're going to have to divide both sides of the equation by 3. That's all they want us to do. Now we're going to see that there are other slightly different steps involved when we divide a fraction by a whole number, but that's not what we're going to worry about right now. They just want you to say that, okay, we've multiplied by 3, now we're going to divide by 3. And I'm sorry about the shadows. Hopefully you'll be able to just ignore them. Problem number 2 is this. It says b over 2 is equal to 4/11. The question is simply, what is going to be the first step that we use to solve this problem? So we look at the variable and we say, what have we done to the variable? Well, b has been divided by 2. So what is the inverse operation for division? If something's divided, what do you have to do to undo that operation? You multiply. So we're going to multiply by 2. And kids, you know this is true, that when we're solving equations, you've got that seesaw thing going on. And whenever you do whatever operation you perform on one side of the equation, you have to perform on the other side of the equation to keep your equation in balance. So if we're going to divide the left-hand side by 3, you have to divide the right-hand side of the equation by 3 as well. So when we say divide by 3, multiply by 2, we mean that we're going to do that with both sides of the equation. Let's look at number 3. Problem number 3, we have 2/3 C is equal to 6. Now, let me take just a second and refer you back to page 225, where they're talking about reciprocals. And they have an example here, and we're going to use this. Because you think, okay, well, what has happened here? C has been multiplied by 2/3. Well, the inverse operation for multiplication is division. So you might think, well, I'm going to divide both sides of the equation by 2/3. Yes, but that can tend to get you really confused looking. I could actually write that out for you, but I don't want to, because I want to go back to what they tell you to do when you have a constant, when you have a fraction that is multiplied against that variable. And it has to do with reciprocals, which are also called multiplicative inverses. Multiplicative inverse. And reciprocals are two numbers that you stand on their head, that their product is always equal to 1. So if you have a fraction, 2/3, numerator over denominator, flip that on its head, 2/3 multiplied by 3/2, your answer is always going to be 1. Your 2's cancel, your 3's cancel, you have 1. You can say 2 times 3 is 6, 6 divided by 6 is 1. Doesn't matter what that particular fraction is. When you take any number, multiply it by its reciprocal, the product is always going to be 1. And the reciprocal is you take the number in rational form, in the form of a rational number, turn it upside down. So, what would the reciprocal of 2 be? Let's go ahead and write that in the form of a rational number where you have a numerator and a denominator. 2/1 times 1/2 is equal to 1. 2 times 1/2. So we have the inverse of a whole number is just the fraction. Okay? And this is the procedure that you're always going to use when you have a variable multiplied by a fraction. We're going to multiply by the reciprocal. That would be like dividing by a fraction is the same as multiplying by the reciprocal. Let me write this down, and that may help someone. If you want to divide by a fraction, well, that's the same as multiply by the reciprocal. This is the recipe that you follow. If you have to divide by a fraction, you multiply by the reciprocal. So what is the reciprocal of 2/3? You find the reciprocal by taking the fraction, standing it on its head. So all they wanted you to say is what is the next step, the very first step you're going to have, and you're going to multiply both sides of this equation by the reciprocal of 2/3, which is 3/2. So we want to multiply by the reciprocal. Now we have, for number 4, 1 3/10 D is 2 3/5. 1 3/10 D is 2 2/5, I think. Let me check. 2 3/5, doesn't matter. What do you have to do to solve this problem here, an equation that has mixed numbers? Remember earlier in the chapter we said mixed numbers have to be converted into improper fractions. So you need to know that 1 3/10 is the same as 13/10. Do you see right now why I've said mixed numbers aren't your friend when you're doing algebra? Because to solve them, you have to convert it into a rational number reduced to lowest terms anyway. Now, you can say, okay, what do I have going on here? This is just like problem number 3. I have multiplied a variable by a fraction, or by a rational number. How do you, since I've multiplied, well, you would think the inverse of multiplication is division, so I should divide by some fraction. Well, we're going to actually do that by multiplying by the reciprocal. So what is the reciprocal of 13/10? Well, you take 13/10 and you stand it on its head, and you see that what we're going to do is multiply by 10/13. That's all I wanted you to understand in these first 4 problems here. You want to make sure that you understand the procedure that you're going to use to solve these problems. All right, now let's see what we have for problem number 5 in our skill check on page 226. Problem number 5, we have solve this. X over 5 is equal to 4. What do we have going on here? As I look for another marker, we have the variable divided by 5. The inverse operation for division is multiplication. So since we divided by 5, we're going to multiply both sides of this equation by 5. Whether you choose to use the raised odd or parentheses. 5 divided by 5 is 1. That's what our goal is here. We now have x is equal to 4 times 5, or x is equal to 20. We've divided by 5. We multiply both sides of the equation by 5. Okay? Problem number 6. Let's see what we have here. Problem number 6, 4y is equal to 3/7. For y is equal to 3/7. Now let me just refer back here in my book just for a second. This is one that they don't give you in a good example from the book. 4. So we have 4 times y. What are we going to do? We want to divide by 4, but if you actually go through and divide both sides of this equation by 4, what are you going to end up with? You're going to end up with something, this is actually called complex fraction, but it makes it unreasonably complicated, unnecessarily complicated for you. So remember we said that when we multiply it by a reciprocal, that's the same as dividing by a fraction. So what if we did this instead? We're going to write 4 as if it were a rational number with the numerator and denominator. 4 over 1 times y is equal to 3/7. Now what do we have? We have this written to where we've multiplied y by a rational number, and we're going to multiply now both sides of the equation by the reciprocal, which is really cool because then you have a very simple problem. Multiply both sides by 1/4. 1/4 times 4 over 1 is 1. So on our left-hand side of this equation, we have y. Now, on the right-hand side of the equation, we have 3/7 times 1 over 4. Multiply the numerators, 3 times 1 is 3. Multiply the denominators. 7 times 4 is 28. And there are no common factors. And what we have here, we see our solution is y is equal to 3/28. Let's go ahead and do problem number 7 now and see what we have here. If I can look at it, we have 2/3 z is equal to 4/7. And you see why I slash my z's and not my 2's, because if I get real lazy, which is the z and which is the 2? The z is always going to have a slash. What do we have going on here? We have multiplied by a fraction. The way to simplify this is to multiply both sides of the equation by the reciprocal of that fraction. If we have 2/3 as our original fraction, we come up with the reciprocal by taking 2/3, standing it on its head to give us 3/2. Now we've multiplied the right-hand side of the equation by 3/2. To keep our equation in balance, we've multiplied the left-hand side of the equation by 3/2. Have to multiply the right-hand side of the equation by 3/2 as well to keep that equation in balance. Now what do you have when you solve this? 2's cancel, 3's cancel. You have z is equal to, now we have 4/7 times 3/2. You could go ahead and multiply numerators, multiply denominators, but you have a common factor. 3 is prime, 7 is prime. Nothing that you can cancel there. However, 4 and 2 are both even, so you divide both of them by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Now, all we have to do is multiply the numerators together, multiply the denominators together, and you have z is equal to 6/7. So that's a very straightforward answer there as well. Now, let's go ahead and look at problem number 8. And the book is continuing to take improper fractions and translate them into mixed numbers. I really, really, really wish they wouldn't do that. As I've said before, either form that you choose to express your answer in is fine. Either an improper fraction, reduced to lowest terms, or a mixed number. Once again, I prefer improper fractions. Okay, this is a little bit different. We have 2/7m is equal to 8/21. I'm going to write myself a note here to remind you guys to go ahead and watch this. 2/7m, that's the same as saying 2/7 times m. Two sevenths times m is 8/21. How can that be? Well, remember, when you have numerators when you're multiplying fractions or rational expressions, you multiply the numerators and you multiply the denominators. So this work that I have shown here, if I would write a 7 instead of a 2, this shows how, okay, and I just said that's 2/7m. And I just misread that. Okay. I think this is straining, going pretty far above what would be a reasonable problem for you guys. Let me see if they have done any more that look like that. Okay. Omit. If you want to solve this problem, figure it out. If you're actually watching this video, if you want to figure this problem out, send it to me. It's worth 2 bonus points on your test for what chapter are we in. Worth 2 bonus points on chapter 7 test. Is something that you're perfectly capable of doing. I'm not going to go into solving it with the denominator with the variable in the denominator. Okay? So if you choose to take the time to solve one of these, either mail it to me or scan it and email it to me, and I will give you extra credit on your test. But again, you have to watch this video to know that. Okay? Moving right along. Oh, and to clarify, there will not be any problems on your test where the variable is in the denominator. I tend to think that they did not intend to have that be the problem, that they intended the problem to be 2/7 times m. But that's not what they wrote down. Okay, problem 9 is 2 1/3 n is equal to 14. 2 1/3 n is equal to 14? Is equal to 14. This is problem 9 of our skill check. Okay? First thing that you do, you've got that mixed number there, you can't work with it. You have to convert that to an improper fraction, which again validates why I say don't worry about converting them to mixed numbers, because you have to go back to an improper fraction anyway. 7/3 n is equal to 14 over 1. We've multiplied by a fraction, multiplied by a rational number. How are we going to solve this problem? We're going to multiply both sides of the equation by the reciprocal of this fraction. So we're going to multiply both sides by 3/7. And then we're going to cancel common factors in the right. 14 divided by 7 is 2. 7 divided by 7 is 1. On our left-hand side, 3/7 times 7/3 is 1. So we have n is equal to 2 times 3, which is 6 over 1, which of course is equal to 6. Do not ever give me an answer where you have something that looks like a fraction with a denominator of 1. Anything divided by 1 is just that number itself. Okay, coming back now, I had to cut out problem 10 because I did that, solved that incorrectly. It's been a long time since I've tried to use my rinky-dink editor to cut out a piece of a video. Hopefully it worked. Okay, back to problem 10. 1 3/5 p is equal to 4/15. This is problem number 10, and let's see what we have to do. We're multiplying our variable by a mixed number, so we have to convert that to an improper fraction. 8/5 p is equal to 4/15. When you multiply a variable by a rational number, by a fraction, the way that you solve that is you multiply both sides of the equation by the reciprocal of that variable. And the reciprocal of 8/5, when you turn it on its head, is 5/8. Now, we could multiply out, but we're going, instead of having 20 over 120, we are going to cancel common factors first. We have p is equal to, 4 and 8 are both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Now we have 5 and 15. Both of these are divisible by 5. 15 divided by 3 is 5. 5 divided by 5, of course, is 1. Now we're going to multiply numerators. 1 times 1 divided by 3 times 2. So P is equal to 1/6. And that would be the end of our examples from the skill check for 7.3, and I'll see you next time.